squared plus b squared equals c.
My man. When did that? Alright, so the first one is a squared plus b squared equals c squared. You guys had that back in middle school. Still gonna have to be on the hook for knowing it. Remember, dealing with a triangle, a right triangle, the c squared, the c term is always the largest, the a term is the smallest one, and you got the b term. Alright, we using that. We also using the distance formula. Find the distance. Find the distance for 2 points. Anybody know the formula?
Yeah.
D,
The square root,
the square root,
and then x1 minus x2 minus x1 squared.
alright?
Y2 minus y1 squared.
Good job. Good job. So you got that, right? After that, so you're gonna have 2 points. You're gonna name your 2 points. You can pick your points either way you wanna pick them, but you gotta stay consistent. So point 1 will be x1, y1, right? Point 2 will be x2, y2. Okay, especially if you wasn't here, make sure you got that down for today. The objective is still saying the same. We still going to be plotting points on a coordinate plane. You gotta know how to do that. We're gonna be doing that, continue doing that. We're gonna do the distance formula. Pythagorean theorem I did put in there, but we use that to derive the distance formula. And we need one more, the midpoint formula. So you got 1, 2, and 3. Can anybody give me the midpoint formula? Midpoint formula. What if I want to find the midpoint between 2 points? How would I do it?
Right, it's like the opposite of that with addition sign.
Yeah, kinda, yes. You take it, but it's always the opposite. You take x1, right, and x2, add them up together, and divide by 2. We take y1 and y2, add them up together, and divide by 2. Basically speaking, we taking half of it. We're taking half of it. Alright, so we're gonna do some application of it. So, example number 6, you should have down example 1 through 5 that we covered the other day. So example number 6 is in your book on page 6, right? It starts off with talking about a football quarterback. It says that he throws a pass from 28-yard line, okay? From the 28-yard line, and he throws it 40 yards from the sideline. Then the wide receiver catches the pass 5-yard line, and he catches the pass 5 yards at the 5-yard line, and it was 20 yards past the sideline, as is shown in this figure here. So we're going to use this. Notice this here is representing the yards from the sideline, and then we got the yards from the pass. So it's like a 20-yard pass, okay? But it went over a little bit. So we're going to be able to calculate the distance. We're going to be able to calculate the distance. Using the formula that we just used. Notice we're going to use this one as an X and a Y. And we just got to keep it very consistent. Got to keep it consistent. So let's pick a point. Which one we gonna pick to be 0.2? 0.2. We'll use this one as 0.2, and then this one as 0.1. So somebody give me, fill it in. Eduardo? 40 minus 20. Square, not the square root, but the square. Plus 28 minus 5. That's it? Square. Alright, and then it's just a plug and chug, do the math. 40 minus 20 is what? 20. Alright. 20 squared is 400. Then we gotta do one more. 28 minus 5 is 23. 23 squared is what? 529. Okay? So we still have this, we still have the square root, we didn't get rid of that yet. So we gotta add these two up together. You get 929. And the square root of 929 is 30. So the distance of his pass was 30-yard pass. It looked like it was 20, but it actually went up and over. Okay? We got a 30-yard pass. What about the next example, example number 2? It started off with telling us the years, example number 7 for us. It started telling us about the Starbucks Corporation. It had an annual sales of approximately 9.8 billion, right? In 2009. So here's the billions here, and it's 2009 here. Now, it also tells us that in 2011 it has 11.7 billion in sales. But the question was, we want to figure out what's the sales in 2010. Well, that's what would be the midpoint. That would be the midpoint. So we have to figure out the correlation. We can use 2009 and 2011 as the y values. X values. So we got 2009 plus 2010, and we're going to divide that by 2. Anybody? Divide that by 2. And that's going to be our x value. And then we got 9.8 billion plus 11.7 billion. And that's going to be divide by 2, and that's a y value. So what's the first one? What's the first one? What's the halfway point between that? You got, right, 10, 2010. What about the halfway, the midpoint for the rest?
I say like 10.6.
10.6?
Cause like that's the 8. It's 9.8 and 1.7. So wherever in the middle of that is.
That's good. Very close. 10.75. Very close.
Switch around at the 8.
Yep. 10.75. So this will be the midpoint. So the midpoint, this will serve as the midpoint right about here. And now this answer tells us that in about 2010, they should have had about 10.75 billion in sales. So we're using the midpoint, we're using the distance formula to be able to try to calculate those different things. It was one other thing, one other example, and it's kind of a little bit outside of the box when it comes to translating. We want to translate objects. How do we do that? How do we do that? The first one here, right? If you look into your book, I try to draw it to scale, but it's not perfect. Okay? We got a triangle. And according to example number 8, it says it's asking us, right? Example number 8 is asking us, telling us the vertices. They gave us -1, 2, 2, 3, 1, and -4. Now they telling us that it's going to shift 3 units to the right and 2 units up. 3 units to the right, 2 units up. So if we got 2 units to the right, 3 units to the right, I'm sorry, we're going to put that here. Remember when I talked about it before, that shift, that's going to tell us if it's going to shift. And we're talking to the right, we're shifting this way. We need to side this whole thing to the right, and that is going along the x-axis. So I'm going to put this 3 here. Note this notation looks a little bit different. You'll see this in physics a little bit. It's like a vector. So this is going to be moving 3 units to the right. If it was going to the left, then it would have been a -3 with the x. And then it also tells us that it's going to go 2 units upward. So the upward, because it's 2 and it's positive, okay? Because it's going up, it's positive. So we're going to be able to take these 3 points here, and be able to shift it over. Now I'm going to apply this rule. Everybody copy this down? You got this? We good? Anybody not good? All right. So we're going to take point -1, 2, and we're going to apply this rule to it. We're going to take 2, 3, and we're going to apply this rule that we're going to use to shift. And we're going to take 1, -4. Watch this. This is very simple. The simple thing is for us to go ahead, right, and add this 3 to the x value and add this 2 to the y value. That's it. So watch this. So if I want to translate this over, shift this over, translate, slide, shift, you'll hear all those terms. All I'm going to do is take -1 plus 3. -1, I'm going to move this out the way. Okay? -1 plus 3 for that term, and 2 plus 2 for this term. Now this is, my math is -1 and 3, we get 2, 2 and 2, simply 4. So this is going to shift, this vertex is going to shift over there. We're going to do the same thing again. We get 2 plus 3, right? And then we get 3 plus 2. Do the math, get 5 and 5. So we start here and we translate over here. We start here, then we translate over here. One more, apply the same rule, 3, 2. 1 plus 3 gives us, okay, 1 plus 3 won't give us the 4, and we got -4 plus 2.
So that's 4.
4 and what?
Negative